This new modular battery called SigenStor is basically going viral across Australia right now. I can tell you the traction this battery is getting in such a short period of time is quite unheard of, but it's for very good reason, and we'll get to all that good stuff in this video. Now, with the new federal rebate about to kick off on July 1 in 2025, more people than ever are now looking for answers as to how does it all work. And what I've noticed is that I'm having these same conversations each and every single day. So I wanted to take the time and create a presentation here today to summarize all the information that I know, my firsthand experience, and I really wanted to just lay it all out for you in a long form video so that you can understand it, digest it, and feel free to ask any questions in the comments below as we go through. So with that being said, let's get straight into it. So here's what we're going to cover. How a traditional solar system compares to the new SigenStor solar and battery combination. The advantages of direct DC inputs into a battery. The ease of installation, scalability, and how that impacts the cost of a SigenStor system. And in summary, we're going to discuss why the SigenStor is crushing it with the Australian federal rebate quite uniquely. So you might be wondering, who am I? I've just popped out of nowhere, but my name's Daniel Isles. I work for PSC Energy, formerly Penrith Solar Centre. Now, I used to be the guy for quite a few years who would be behind the scenes and make the videos for Penrith Solar Centre. Yeah, I spent a good 2 years basically working very closely with the installers on site to create the content that you might have seen on Penrith Solar Centre's YouTube. But now in 2025, I've moved over as a design consultant to work directly with mums and dads and help them understand the madness of solar and battery right now. Even more so with all these rebates coming in, really pride myself, and so does PSC, on educating our customers as much as possible so that they can make a great decision. Because ultimately, if solar and battery is done well, it has such amazing potential to fully remove an energy bill from your expenses, from your budget, basically. And there are not a great deal of things that you can invest in today that gives you a sense of freedom like that. So the topic of today's video is why SigenStor is crushing it with the Australian solar rebate. And we're going to get started with a solar and battery basics, because this information is important to understand because it all ties into the value of SigenStor. So it's really important we understand how solar and battery works on a fundamental level. So solar panels generate power in DC, which is direct current. Our homes and the distribution grid operate in AC, which is alternating current. To convert DC to AC or vice versa, you need an inverter. Now, this would traditionally be a string inverter, or it could be a microinverter, which is a small inverter under each and every single panel. Or it could be a hybrid inverter, which is built into the battery, just like SigenStor. Batteries store energy in DC, direct current. So there's a DC to DC relationship between the panels on the roof and the battery on the wall, where you don't need an inverter if you can directly connect the two together, which is the era that we're in now with batteries like Powerwall 3 by Tesla and SigenStor by SiGenergy that have direct solar inputs into the battery, allowing the benefits of this DC to DC relationship between panels and batteries to exist. So let's quickly look at a traditional solar setup so you can kind of visualize and contextualize the differences between a traditional string inverter AC coupled system and what that looks like retrofitting a battery and direct solar inputs into a battery. So a traditional system, as I just mentioned, the panels generate DC and everything is sent to the inverter and that converts it to AC. The home consumes power in AC, and then all it's got to do is export any excess AC power to the grid. Now, one important thing to mention is there'll be a lot of people. I myself, 7 or 8 years ago, purchased a 6.6 kilowatt solar system. What that actually is, and that's probably the most popular solar system on average in Australia, up until recently where 10 plus became common ground really. But 6.6 kilowatts of solar actually has a 5 kilowatt inverter attached to it. So you might have 15, 20 panels, depending on what year you purchased your 6.6 kilowatt system. But the maximum output in AC of that system will only ever be 5 kilowatts. This is because it's taking advantage of a 33% oversizing rule, which I believe the energy distributors or maybe the energy regulators came up with this particular rule, which basically meant that because solar panels only generate their maximum output for a very short period of time during the day, basically when they're in full sun, other than that, every other time of the day, the panels are producing like less than their maximum rated output. So to sort of combat that and allow systems to produce more power throughout the day, they allow us to oversize the solar to the inverter by 33%. And that rule has served the industry quite well. It's served homeowners quite well in being able to give them more performance out of their 5 kilowatt inverter. But what that means is 1.33 kilowatts of solar never has an opportunity to become AC. It's just basically lost. Whereas if you had a direct DC input system at 6.6 kilowatts of PV, you actually have the ability now to use all 6.6 of that PV production, if in fact it was all producing at one time, and you could actually divert that directly to your battery. So there are all sorts of advantages which we'll get into, but that is one of them where, in fact, the oversizing rule of solar and battery systems combined, like Powerwall 3, like SigenStor, is 200% oversizing rule, because you've got the battery built in to, like the inverter built into the battery, and the system's solar's plugged into the system, and it's all in one. So that's a little bit off topic of today's video, but that's just where the progress of this technology is going. It's been 33% oversizing rule forever, up until this technology around a year or so ago. Not even a year ago. It was like November last year, Tesla released Powerwall 3, which has kind of started, like put all this on the radar with direct solar inputs into a battery. So how a battery retrofit would work to this existing system, it would have to be what's called AC coupled. The panels generate DC power, as we know. The inverter inverts it to AC. It's the first priority. It sends power to the home. The second priority is it diverts any excess now to the battery. But the problem is it's already AC because there's no direct connection between panel and battery in an AC coupled existing system. So what the battery has to do is now invert it back to DC just to store it, and it loses about 3 to 5% of energy, or of power rather, in that process, which isn't a huge deal, but it is losses. And then when it needs to deliver power to the home later in the evening, it actually has to invert it back to AC once more, so the home can consume it, or if you're on a VPP like Amber or something, you can send it to the grid. So you're doing that initial inversion, unfortunately, for not a great deal of benefit. Whereas if you had the direct DC inputs, you could just do that without virtually any losses. So let's look at now the direct DC inputs into the battery. And these are basically some of my favorite talking points, some of the key benefits that I bring up to my customers when I'm designing the solar and battery for them. So panels produce power in DC and can directly charge the battery, bypassing the inverter completely. The inverter's workload is virtually cut in half. If you go back to what we just went through, the conversion of AC to DC happens in a traditional system because there is no pathway for the DC to get to the battery. It's got to go through that inverter. Whereas here, we avoid that by bypassing the inverter. This means every single cell in your panel can be put to work to charge your battery. Only when the home needs power, or when it's ready to export to the grid, will the inverter be called upon to invert the DC to AC so it can be used. So because of that, you get system efficiency gains. All power captured by the panel can be immediately stored in the battery with little to no losses due to the DC to DC connection. This means longer inverter lifespan. The inverter is not needed to charge the battery anymore. This means greater reliability and longer inverter life. The direct DC car charging capability with SigenStor is pretty cool. This gives you more options to send your excess DC power somewhere other than your battery. EV charging is a heavy demand on your electrical system at home, and not having to use an inverter to charge an EV is more efficient and less work on the inverter. You just have to make sure you install your battery near the garage for this, because the DC charging module is actually built as a module in the SigenStor stack. So yes, you can't effectively DC charge your EV with SigenStor unless your battery is located within maybe 7 to 10 meters from where you can get a car access to the battery. But I will say that I'm not an expert at all on this DC charging yet. It's all very, very new. It's quite expensive too, the DC charger from SigenStor. They do have an AC charger version, which is comparable with most other chargers out there on the market. But yeah, I guess the potential of this again is just bypassing that inverter completely. If you've got a nice big solar system, you can just send all that DC directly to your vehicle, which is very, very cool. And what my research currently has led me to understand is that vehicle to home and vehicle to grid capability with SigenStor is very much centered at this stage, it seems, around the DC charger. So yeah, that just means at this point in time, it seems like the AC charger won't have access to that vehicle to home, vehicle to grid capability. This isn't a thing yet in Australia, but SigenStor's hardware, software is, from all intents and purposes, ready for it, which is really cool. But it's certainly not a thing yet. But from what Sigen is saying, it's very much specific to the DC charger. Let's talk about installability, scalability, and how that impacts system costs. And this is something that I think other manufacturers are sleeping on, like making it as easy as possible to install and making the design of the battery as flexible as possible to accommodate different styles of homes. And we'll get to that right now. So the SigenStor is a modular battery. It's stackable. At PSC Energy, we just use the 8 kilowatt hour battery modules. It's plug and play, and there's no hard wiring the battery modules together. So it's very much just sit the battery, stack it on top of each other, and the terminations and the commissioning happens all at the end once the stack is virtually complete. So it's easy to scale on site. Now, the battery scales vertically. And clear wall space is much easier to find vertically on homes compared to horizontally. The further you go down an external wall, and feel free to look down the side of your house, after watching this video, and let me know how many things are up the side of your house, with your AC units, air conditioners, like water tanks, hot water systems, like all of these things are problems when it comes to installing battery storage. We need minimum clearances of up to 600 millimeters from most of that stuff to be able to comply with the current regulations in Australia for installing batteries on homes. When you have a battery that scales vertically and it doesn't take any more width than what it does between 8 kilowatt hours and 48 kilowatt hours, you've now got a system that's really flexible for the typical average Australian home to be able to fit this thing in their property without having to pull hose reels off the wall, change things up. Like it's a real challenge to fit some of these wall mounted batteries up the side of people's homes, in their garage and so forth, because space literally becomes a limiting factor, but not with the SigenStor. Another super interesting point the labour to install 8 kilowatt hours is virtually the same for 48. Now, it's not exactly the same, but it's in the same ballpark because there's no hard wiring between battery modules. It's plug and play. And once you've got your bottom base fixed, which is arguably most of the work is to set the base, to level a pad on the ground, set the base, and once that's in, your first battery goes down and all your subsequent batteries go down after that, stack on top and top and top until the inverter module, which has the circle indicator light on it, that's the inverter and all the sort of brains of the battery up top. That goes on at the end, and the electrician will basically complete their wiring of the system from that point. So yeah, it's just once you've got the base set, which is all the hard work virtually from what I've been told from the guys, it's good to go. Which is complete contrast to traditional batteries that require wall mounting brackets and in some cases physically hardwiring the 2 or more batteries together. And this has a dramatic impact on labor costs. So we're going to quickly look at a chart I've whipped up just quickly here in Canva, and I'll show you this now, of how the Australian rebate is calculated based on kilowatt hours of storage and the time it takes to install. So this is the install time against the federal battery rebate comparison in Australia. So this is typical batteries, right? The federal rebate kicks off at around 5 to 8 kilowatt hours of storage, and it goes to 48 to 50 kilowatt hours of storage in a linear fashion. The price per kilowatt hour is roughly $350, $360 per kilowatt hour, and that just scales in a very linear fashion to its maximum at 48. The install time on typical batteries, the minimum time to install an 8 kilowatt hour or 10 kilowatt hour battery would be here, and that scales in a pretty linear fashion as you go up as well in time on site to install the storage. And this is where SigenStor blows everyone out of the park. The time it takes them, or takes us, to install an 8 kilowatt hour module versus 48 kilowatt hour module is virtually the same. But the federal battery rebate, the price you're getting per kilowatt hour, continues to increase. So when the labor costs and the material costs to install more storage are virtually the same, within hundreds of dollars, they're not the same, but they're within a few $100, maybe $1,000, let's say, pretty wild. But the thing is with SigenStor is that it offers whole home backup, and switchboard upgrades are required to install SigenStor. The SigenStor's gateway offers whole home backup, which is an awesome feature if I'm being completely honest. It's totally awesome that you can get whole home backup from a 3-phase inverter, single phase inverter, whatever you've got. The thing is that all circuits must be RCD protected in order to do that. That's a residual current device. Now, if you look at your own switchboard and see your circuit breakers with this little test button somewhere on the breaker, that's highly likely a RCD breaker, which means you're in a good place for your switchboard for that particular circuit. You now just need to check the rest of your circuits and see if they're RCD protected. If they're not, your board will need to be upgraded to ensure that all breakers are RCDs. It's tied in with the battery standard, I believe, the electrical standard. It's not something that's overly new, but because this gateway doesn't offer partial backup, it only offers all or nothing backup, we then have to comply with the regulations to ensure that all circuits are RCD. So that just means that you may be up for some additional costs to upgrade your board, but it does make your home and board much safer with RCDs throughout. And just to throw out my quick opinion on the board upgrade thing, vehicle to home and vehicle to grid functionality is obviously coming here in Australia at some point in the future, but that will bring greater scrutiny on main switchboards and heighten the importance of safety and quality electrical workmanship in your main switchboard. I don't think the energy distributors around the country are going to just open borders as far as the let everyone just plug their cars in and let people start drawing and sending huge volumes of power to and from the grid, to and from their home, without a lot of scrutiny and inspections and criteria around the state of the electrical system in their home. So yeah, it will be, if you are looking at SigenStor and you're talking to an installer and they're telling you that you need their board upgraded, this is only a good investment to make for the future for things like this. I think board upgrades will take it to another level when this stuff actually gets released and laws are actually written about it, standards are written about it. But right now, the more we electrify our homes, I think a very high emphasis needs to be put on safety and quality workmanship of your solar and battery installations. So in summary, why SigenStor is crushing it with the Australian federal rebate? It's because the direct solar inputs into the battery. Solar and battery inverter is now all in one. More of your power is captured since the inverter is bypassed to charge the battery at the maximum output of the panels. It's not throttled by the inverter in between. There's no middleman at all. Whatever that panel can produce at any one time, it can virtually send all of it to the battery built into the SigenStor. This means that there's less work for the inverter, making a more efficient system with less conversions back and forward to DC to AC. There's fast and flexible installation. This reduces installation time, this reduces installation costs, and it's easy to add storage with a vertical modular system on site. And the unique value proposition with the federal rebate means that you can get a lot more storage for a little additional cost. If you live in the Sydney, Blue Mountains or Bathurst region and you're interested in solar and battery, I'd be more than happy to help you out with a free consultation and quote from me at PSC Energy. Thanks for your support and I look forward to seeing you on the next one.